สวัสดีครับ Hello teacher my name is ชัยวัฒน์ชิมทองรหัสนิสิต633611467 Today I will to present chapter 4 Trade and Concurrency Okay let's go Outline Overview Multi-core Programming Multi-threading Model Trade Library Implicit Trading Trading Issuer Operating System Example Next slide Objective Identify the basic components of a trade and contract trade and processes. Describe the benefits and challenges of design multi-trade application. Is to trade different approaches to implicit trading, including trade pool, structure, and grant center dispatch. Describe how the Windows and Linux operating system represent trade. Design multi-thread application using the pre-trade Java and Windows trading APIs. Okay, next slide. Motivation most modern applications are multi-threaded. Thread run within application. Multiple tasks with the application can be implemented by separate threads. Update display, fetch data, spell checking, answer a network request. Process execution is heavyweight, while trade action is lightweight. Can simplify code, increase efficiency. Kernels are generally multi-threaded. Next slide. A single and multi-thread processes. This photo, okay, the working single-thread process, multi-thread process, okay. Single thread one line and thread multi-thread คือใช้โค้ด Data ไฟล์ร่วมกันครับผมแล้วก็แต่งมาเป็นแถวอย่างนี้โอเคต่อไป multi-thread service architecture clean server thread server create new thread to server request resume listening for addition client request okay next slide benefit responsiveness may allow continuous execution if part of process is blocked. Especially important for user interface. Resource sharing, trade, share resources or process easy, then share memory or message passing. Economy, sharper than process execution, trade switching, lower overhead. Scalability, process can take advantage of multi-core architecture. Multi-core programming, multi-core of multiprocessor system putting pressure on programmer challenge incur driving activity balance, data splitting, data dependency, testing and debugging, parallelism implies a system can perform more than one task, simulate concurrency, support more than one task tracking package, single processor core, scheduler module concurrently, execution concurrent parallel. Okay, next slide. Concurrent execution of single core system. Single core system is working the photo list. Parallelism on a multi-core system. Okay, next slide. Type of parallelism, data parallelism. Distribute subsets of the same data across multiple core, same operation on each task. Parallelism, distributing tests across core is test. Performance unique operator. Okay, This photo working is a data and task parallelism. Adam Roth identify performance gain from adding additional core to an application that has both serial and parallel components. S is serial function in processing core. That its application is 75% parallel slash 25% serial. Moving from 1 to core result is speed up of 1.6 times as n equal as infinity speed up. Serial version of an application has disproportionate effect on performance gain by adding additional core, but that does not take into account contemporary multi-core systems. Okay, is Adam's law. User thread and kernel thread. User thread management done by user level thread library, 3 primary thread library, POSIX thread, Windows thread, Java thread, kernel thread, supported by the kernel. Example, study and generate for operating systems including Windows, Linux, Mac OS X, ISO, and user and kernel thread. User thread, kernel space. Multi-threading model, many to one, many one to one, many to many, many to one, many user level thread map to single kernel thread, one thread blocking case or to block. Multiple thread may not run in the parallel on multi-core system because only one may be in kernel at a time. Few systems currently use this model. Solar Green thread, GNU portable thread, okay, many to one. User thread to many and kernel thread 1. 1 to 1 is user level thread map to the kernel thread. Hitting a user level thread create a kernel thread. More concurrency than many to one. Number of threads per process sometimes. This due to overhead. Example, Windows, Linux, okay, 1 to 1, this photo. Many to many module allow many user level threads to be mapped to many kernel threads. Allow the operating system to create significant number of kernel threads window with the thread fiber package. Alright, that's really common. Okay, user thread is a 4, kernel thread is a 3, many to many. Next slide. Model similar to M except that it allows user thread to be born the kernel thread. This is many to many. Thread library. Thread library provides programmers with API for create and managing thread. Two primary ways of implementing library entity in user space. Kernel level library support by the OS. Pthread may be provided either at user level to kernel level, a POSIX threading API for thread execution and synchronization, specification, not implementation. API specific behavior of the thread library implementation is up to development of library common in the unique operating system. Pthread example, okay, is source code. Next slide. Pthread example count is a C language. Okay. Pthread code from joining 10 thread. Implicit threading going in the popularity as number of threads increase program clearness more difficult with explicit thread session and management of thread done by compiler and runtime library rather than programmer. File method exploit ch4 fork open MP create of number a thread in a pool where they avoid work. Advantage usually slightly faster to serve a request with existing thread than create a new thread. Although the number thread in the application to be one to the size of pool, separating tasks of be performed from machines of creating task although different strategies of for runner tasks. Windows API support thread for multi-thread and fork and the joy. The photo is a working fork joy parallelism. Fork joy parallelism. Okay, so general algorithm for fork joy is the source code fork joy. Fork joy is a working this photo. Okay, open MP. Set the compiler directive and an API from C++ for Tran. Provide support for parallel programming in shared memory environment. Identify parallel region block of code that can run in parallel. Okay, this is source code. Threading issue. Semantic for of fork and system call signal handling, synchronous and synchronous thread cancellation of target thread. Asynchronous of deferred thread local store scheduler activation. Semantic of fork and X. That fork duplicate only the calling thread of all threads. Some Unix have two versions to fork. Usually work as normal replace in running process, including all threads. Signal handling signals are used in the Unix system to notify a process that a particular event has occurred. A single handler is used to process signal. Signal is generated by particular event. Signal is delivered to a process. Signal is handled by one tool. Signal handler default user default. Every signal of default handler task kernel run when handling signal. User defined signal handler can override default forcing signal delivered to process. Signal handling where should the signal of delivered from a thread deliver the signal of the thread with the signal applied deliver the signal to every thread in the process. Deliver signal of certain thread in the process. Extract a specific thread of receive or signal for the process. Thread cancellation terminating a thread before it has finished thread to be cancelled in a target thread. To general approach as synchronous cancellation terminate the target thread immediately. Deferred cancellation allow the target thread to periodically check if it should be cancelled. Repeated code to create of cancel. Okay, is code short code. Thread cancellation invoking thread cancellation request cancellation but actual cancellation depends on thread state. If thread has cancellation disabled, cancellation remains pending until thread enable it. Default type of defer cancellation only occur when thread is one Linux system thread cancellation is had the trunk signal. Operating system example Windows thread, Linux thread, Windows thread, Windows API, primary API for Windows application, implement of one-to-one mapping, current level, a thread, current, a thread is ID, register set, representation state of processor, separate user and kernel stack from when thread run in user module or current mode. Private data store area used by runtime library and dynamic link library. The register set stack and provide strong area are known as the context of the Linux thread. Linux refers to them as tasks rather than thread. Thread creation is done task clone system call clone or row assign task of share the s the space of the parent thread. Flag control behavior. Okay, thank you for listening and watching. Goodbye.